Hello and welcome to this video. In this video, we are going to be talking about fine-tuning, and we are going to be fine-tuning a large language model using Unsloth and hosting the model on Hugging Face. Now, what is fine-tuning? Fine-tuning is the process of modifying the training weight of a foundational model. So you have a base model, a base LLM, and you decide to retrain that model so you can have information about your own specific domain. So most LLMs are trained on generic data, so they are general purpose models, but you want it to have information about your specific domain, and so you get to fine tune them. So let's look at the processes of fine tuning. First, you have to find a base model, and for this particular tutorial, I'm using Microsoft File. That's the model I'll be using. And then you prepare the training data. Now, every large language model has a structure for the way its original training weight was trained, right? So it has the average structure and a template. And you will find for the models that we are using, for the models that Unsloth gives us access to, they have a template, and you find those templates on the Unsloth documentation page, so you can see how to structure your own data. Now, for this demo, I went ahead to ChatGPT and I just created like an imaginary company and said, give me data for a Microsoft Phi model, gave it the template, gave it an imaginary company, and it just went ahead and created the training data that I needed in the template of Microsoft Phi. So that's an approach you could use. And then you train the model. So Unsloth gives you scripts and methods that you could call to train the models that they have on their platform. So you could pick a model, prepare your data to make sure it's according to the template of the model that you've picked, and then you just train the model. And then next you host the model. So for this demo, I'm hosting the trained model on Hugging Face. Hugging Face gives you storage. I think for the free plan, you have storage of up to about 100 gig. So you can host your models on Hugging Face. Now you could also host on maybe SageMaker or any other platform, but I'm using Hugging Face because there's a free plan. All right, so let's get into the Google Colab and I'll show you everything. All right, so here's the Google Colab, and this is the code and everything that I'm using to fine-tune the Microsoft Phi model. So first things first, I come into my Colab environment, and then I connect. So I choose a runtime. So when you come in, I think by default the runtime is set to CPU, but because fine-tuning we use GPUs, and there's a free T4 GPU here. You have to change the runtime, and so I'm setting it to T4 here, and I'm saving, and I click on connect. So it's going to connect me now. Cannot connect to GPU backend. Oh, I've exhausted my limit for the day. Yeah, so I was playing with it earlier. So basically that's what you have to do. Just connect to the GPU, and then do all your installations. So here I'm uninstalling WAND. So I noticed when I first ran the training script, it gave me an issue. This WAND package gave me an issue. So I did a little search, and the responses I got was to uninstall the wand and essentially just disable it. And that's what I did. And also I had an issue with this dataset and PyArrow package as well. So this was the response I got on how to fix it, and I just set it like this and it worked. So yeah, this cell disabling wand, and then yeah, another thing is this Unsloth. It's recommended that you import Unsloth before anything else. Make sure you import it like first in your imports basically. So that's what I'm doing here. Just import Unsloth, and then you can also this is just for housekeeping to be sure that we have GPUs available. Right now I can't connect to I think I've exhausted my limit and I can connect there. So next you mount your Google Colab. So for the Google Colab, I'm using Google Drive. So sorry, you mount Google Drive. So for Google Drive where I'm using Google Drive for my data set. So I upload my data sets to Google Drive, and then I mount the drive here in this cell, and then over here I just run a script to test whether the Colab is able to access my script. And you can see, I think I tested this earlier, and you can see the response down here. It's seeing it, the JSON-L document, and it's able to read from it. So that means our data is good. Now the training script. So first things first, we do all the importation, import all the packages, and then we load the data set, loading the data set, and then we load the base model, which is Microsoft i3 Mini 4K Instruct. That's what we're using. Then we prepare the LoRa, the low rank. So all these parameters, you'll find it on Unsloth documentation. I'll put a link to the documentation in the description, so you can, if you want to read more about what each parameter does, you'll find it there. So next phase, the formatting function. Now, this is the format that Phi3 expects your data to be in, right? So currently our data is in, let me see. Can't even connect that. So our data is in this format. You can see it. So it's in this particular format: message, array of object, continue role, system content, role, user content, role, assistant content. So that's how I prepared the data. You'll find the data in I'll put a link to the GitHub repo, and you'll find the data and everything there. So with this formatting function, we get to format that data and just modify it to the format that Phi3 expects it. So we'll do all that in here. And yeah, training arguments. So all these parameters here, you find an explanation to them on the Unsloth's documentation. So if you want to read more about them, but these are all the parameters here. So for this particular one, output directory. So I'm setting my output directory back to my Google Drive. Now, there's another parameter that you could put in here that will prevent you from saving, because really you don't even have to like save it, because this, because I'm already pushing it. If down here you can see I'm already pushing the LoRa adapter and the LoRa weights to Hugging Face. So we really don't even have to save it here. But this was what I was just playing with the script initially. I set it to save it to my Google Drive. So that's why it's still here, but you could remove it depending on whatever strategy you decide to go with. So here's the trainer. So all the parameters as well. So remember the formatting function, we'll pass it in there, and every other thing we need. And then we'll call the train method. So when you call this train method, it starts the training. And then once the training is done, then we connect to Hugging Face, and then we log in. Now to log in, I'm taking a token from Hugging Face, which yeah, so it's here, Hugging Face token. Let me show you where I got this token from. So if you go to Hugging Face, huggingface.token, this particular website, I'm already signed in. So Hugging Face, to access token, you go to access token down here, and here this is the token. So you just create your own token here, and make sure you give it the right permission so Colab is able to so the token has the right permission to be able to create a repo and create whatever other thing that it needs to create. So you give it a name and then you click on create. I'm not going to do that because I already have it here. So that was what I did there, and then I got the token and put it here, and then I gave it a name. Now note this name because you're going to need the name here, right? So it has to match. So I use the name here, and yeah, I provided my username, which is the username of my Hugging Face account here. Provided the username, and then I provided the name for the model. Just gave it the name. So I got a random company information from ChatGPT. So I just gave it that name. Yeah, so I pushed the LoRa weight. Now it's going to create two repos. One is for the LoRa weight and one is for the meshed model. The LoRa weight is all the training information that you use for this particular training. So to create a repo with all that information for you. Now you will need that weight if you need to do another iteration of maybe another training. You can easily just pull from there and then you retrain again. But this one is the meshed version, which you can take to production after your training. So this is the one that is like the one you can use for inference and for production. But this is just for your LoRa weight training. And if you can see, as you can see here, we have private set to true. So it means the repo that it will create is going to be private. It's not going to be public. And also here. So once it's done, you'll find your LoRa model here in this link, and you find your meshed model here in this link. Now I'll show you the models here. So yeah, so this is the model. This is the Acme Phi 3 assistant that I created, and then this is the Acme Tech Phi 3 assistant LoRa that I created. So this is the LoRa, and then this is the main model. Now it's private, like you can see, it's private because of that parameter that we set there in Colab. Over here, I'm doing something, I'm running a test. So you can just run it from here, like from this particular point. And then you will see the response that the LLM, the model that you've fine-tuned generates. You can get it here. Now I'm adding this login in this phase. The reason I added this was I didn't want to, you saw that issue just now of not able to connect to a GPU. So I've already hit my limit for the day. And so when I was playing around with it earlier, if I ran this particular cell, then I wouldn't need to add this login because I already have the login call here. I already did all the login and everything here. But because at the time I didn't have I wasn't able to run, I already ran this and I'd already hit my limit. So I had to bring in all the importations again down here and then call the login again down here so I could have a new section, to log in. So when I ran it, it gave me the information that I needed, but right now I can't run it. I can't really test because I've hit my limit. So yeah, that's the whole process, and it's up on my Hugging Face account. Now you can also upload the model to maybe SageMaker and get an inference API from SageMaker to use, but I'm using Hugging Face because they have the free plan that I could play around with, and that's all. I'll put the link to this particular Colab and the link to Unsloth on their documentation, Unsloth AI documentation, and also the link to my GitHub repo for, I'll just put a link everything down in the description to this video. All right, so that's the video on fine-tuning. Now you could use this particular let's say a company wants to have a chat application about their knowledge base and they want to use AI. You could use this, or you could use retrieval augmented generation. So in retrieval augmented generation, we are getting the information, passing it to the context and sending it to an LLM to give us a response. But with this, we are modifying the LLM. We don't need to pass anything to the context. As the user is querying the LLM already has information about our business, and it uses that to generate the response. Now, there's an approach that I've seen in production where they combine retrieval augmented generation with fine tuning, and the reason for that is if your company information changes over time, right, and you don't want to keep fine tuning, keep retraining the model, you can combine this. You can train the model with your company information once, and then subsequent, if there is any change to your company information, you can pass that information through RAG to the context and send to the LLM and tell the LLM, maybe just put in the prompt, use this context to generate a response, right? If it's not able to generate a response, then use the model to generate the fine-tuned model to generate a response. But if you can't find information about that with the fine-tuned model, then use the RAG. So you can just modify that in your prompt. But that's an approach I've seen people use in production. So yeah, that's the video on fine-tuning. And thank you for watching. Kindly like and subscribe to the channel, and see you in the next video.